Welcome back to the architecture of creation. We have come a long way through this series. In our prior episodes, we have established the three-layer architecture, the primordium, the rendering interface, and manifest reality at layer 3. We have engaged matter as coherent vibrational patterns within the substrate, energy as boundary phenomenon, time as a layer 3 feature. We have developed the resilient substrate as the active architecture that maintains the conditions for reality with its empirical signatures, its conversion mechanism, and its constitutional ontology as a field of organizational energy. We have engaged the four forces as substrate coupling modes and gravity as substrate distortion with Newton's mathematics and Einstein's geometry, both preserved within the framework. In this episode, we turn to the largest and smallest scales of the architecture. Cosmology, where the framework's account of the substrate plays out at the size of the universe. And quantum mechanics, where the framework's account of the rendering process plays out at the smallest scales we can observe. Two parts, Part 10 and Part 11. Cosmology Reframed and Quantum Reconciliation. We begin with Part 10. Mainstream cosmology, developed across the 20th century and refined throughout the early 21st, has produced an empirically extraordinary picture of the universe at the largest scales. The expansion of space discovered by Edwin Hubble in the 1920s, the cosmic microwave background discovered by Penzias and Wilson in 1965, the accelerating expansion confirmed in 1998, the increasingly precise mapping of large-scale structure by surveys including the Sloan Digital Sky Survey and the Dark Energy Survey. The measurements are extraordinary, but the conceptual landscape they describe is in serious trouble. Dark matter and dark energy together account for approximately 95% of cosmic mass energy by mainstream estimates, and neither has been directly detected after decades of effort. The cosmological constant problem represents one of the largest disagreements between theoretical prediction and observation in the history of physics. The fine-tuning of cosmic parameters has driven mainstream cosmology toward multiverse speculations that are themselves not testable. The homogeneity assumption underlying the standard cosmological model has been under increasing observational pressure. The framework reads cosmology differently. Cosmology, the framework holds, is the visible operation of the conversion economy at the largest scales. The phenomena mainstream cosmology has measured separately: dark energy, dark matter, the cosmic microwave background, the fractal structure of large-scale matter distribution, are aspects of one operating architecture. Part 10 develops what the framework's reading reveals when these phenomena are recognized as facets of the same underlying system. The framework holds that observations approaching 300 million light-years should reveal fractal structure rather than true cosmic homogeneity. This is a structural prediction. The substrate has structural features that propagate through the medium at the rendering rate. At distances approaching 300 million light-years, the cumulative effect of these structural features begins to dominate what observation can directly reveal. Mainstream cosmology has assumed that the universe is homogeneous at all sufficiently large scales. This is called the cosmological principle. The framework predicts that this assumption fails at the rendering boundary, with fractal structure observed instead. The cosmological principle in the framework's reading holds at scales below the rendering boundary and breaks at the boundary itself. The Vera Rubin Observatory, the Square Kilometer Array, and other instruments now coming online should reveal this structure as observational refinement proceeds. The prediction is testable. If observation continues to confirm homogeneity beyond 300 million light-years with no fractal structure emerging, the framework's account of the rendering boundary fails. If fractal structure emerges as predicted, the framework's account is confirmed. The boundary itself is not a wall. It is the limit of what the rendering process makes directly observable. The universe continues beyond the boundary. We simply lose direct observational access to what is there. The framework holds that observations approaching 300 million light years should reveal fractal structure rather than true cosmic homogeneity. This is a structural prediction. The substrate has structural features that propagate through the medium at the rendering rate. At distances approaching 300 million light years, the cumulative effect of these structural features begins to dominate what observation can directly reveal. Mainstream cosmology has assumed that the universe is homogeneous at all sufficiently large scales. This is called the cosmological principle. The framework predicts that this assumption fails at the rendering boundary, with fractal structure observed instead. The cosmological principle in the framework's reading holds at scales below the rendering boundary and breaks at the boundary itself. The Vera Rubin Observatory, the Square Kilometer Array, and other instruments now coming online should reveal this structure as observational refinement proceeds. The prediction is testable. If observation continues to confirm homogeneity beyond 300 million light years with no fractal structure emerging, the framework's account of the rendering boundary fails. If fractal structure emerges as predicted, the framework's account is confirmed. The boundary itself is not a wall. It is the limit of what the rendering process makes directly observable. The universe continues beyond the boundary. We simply lose direct observational access to what is there. Three of mainstream cosmology's biggest puzzles dissolve when read through the framework's architecture. We named them in episode 5 as signatures of substrate energy. Here we develop them at cosmological scale. Dark energy. Mainstream cosmology attributes accelerating cosmic expansion to an unknown component constituting approximately 68% of cosmic energy density. The framework reads dark energy as substrate energy observed through its effect on cosmic expansion at the largest scales, the medium's own energetic character made visible, dark matter. Mainstream cosmology requires approximately 27% of cosmic mass energy to exist in unknown matter to explain galaxy rotation curves, gravitational lensing, and the structure of the cosmic microwave background. The framework reads dark matter as the substrate manifesting gravitational behavior at galactic and cluster scales, not a particle. Quantum foam. John Wheeler, in the 1950s, posited chaotic fluctuation of space-time itself at the Planck scale. The framework reads quantum foam as the visible flicker of the rendering process at the layer 2/3 boundary, the fundamental discreteness of the rendering process manifesting at the scale where that discreteness is observable. 3 puzzles, 3 dissolutions. Each yields to the same architectural reading. Substrate energy made visible at different scales of observation. We develop dark energy and dark matter next. The 1998 discovery by Saul Perlmutter, Brian Schmidt, and Adam Rees that the universe's expansion is accelerating won the Nobel Prize in Physics in 2011. The measurements were decisive. Distant supernovae appeared dimmer than the expected expansion rate would predict. The conclusion: cosmic expansion is accelerating, not decelerating as previously assumed. Mainstream cosmology incorporated the discovery by positing dark energy, a mysterious component constituting approximately 68% of cosmic energy density. No direct detection of dark energy has occurred. The cosmological constant required to model the observations is approximately 120 orders of magnitude smaller than naive quantum field theory predictions. The cosmological constant problem. The framework reads the same observations through a different lens. 2 factors contribute to what observations have registered as accelerating expansion. The first is a perspective artifact. Light from distant supernovae traverses enormous distances of active substrate, accumulating effects that mainstream cosmology has interpreted as expansion alone. The second is increasing substrate tension as cosmic conditions evolve. Both contributions together produce what observation registers. Neither requires dark energy as a separate substance. The substrate's own energetic character, as Episode 5 established, is what dark energy actually is. The constancy of dark energy density across cosmic time, which has puzzled mainstream cosmology, is what we would expect if the calibration is actively maintained by the conversion economy. The substrate sustains its own energetic character because the architecture maintains the conditions for it to do so. Vera Rubin's measurements of galaxy rotation curves in the 1970s established that galaxies rotate as though they contain substantially more mass than is visible. Gravitational lensing observations confirmed similar patterns at cluster scales. Mainstream cosmology posited dark matter, invisible matter constituting roughly 27% of cosmic mass energy. The framework reads these observations as evidence for the substrate manifesting gravitational behavior without electromagnetic coupling. The substrate has its own intrinsic structural properties that produce gravitational effects without electromagnetic interactions because the substrate is not matter. The empirical evidence for this reading continues to accumulate through what is not being found. For nearly 4 decades, physicists have searched for dark matter particles through underground detectors. The Xenon collaboration, the LUX experiment, and its successor, Lux Zeppelin, the Panda-X program, the Super CDMS experiment, the Cresty experiment, the Dama/Libra experiment, and many others have collectively run for decades at increasing sensitivities. Each has produced null results or contested findings. The framework predicts that direct detection experiments will continue to yield null results, regardless of how much further sensitivity improves. Dark matter particles cannot be detected because they do not exist as a separate category. What is being detected gravitationally is the substrate. The substrate cannot be detected as a particle because it is not one. 4 decades of null results on the framework's reading are not a string of bad luck. They are the experimental signature of looking for the wrong category of thing. What we have done so far in Part 10 resolves 3 of cosmology's largest puzzles. But it leaves a deeper question. Where did the matter come from? When in cosmic history did substrate-to-matter conversion occur? The framework's answer extends the conversion mechanism established in Episode 5 to cosmological history. The early universe was the era of large-scale substrate-to-matter conversion. When energy concentrations were sufficient, the conversion mechanism articulated in Episode 5 operated at cosmological scale. Substrate energy was locally converted into transient, coherent vibrational patterns. Some of those patterns achieved stable, coherent organization. The matter we observe today is the result of those early conversion events that successfully stabilized. The Big Bang, in framework terms, is reframed, not matter and energy coming into being from nothing. The rendering produced the substrate with conditions sufficient for large-scale substrate-to-matter conversion. The visible cosmic history we observe is what unfolded once the substrate was rendered and the conversion conditions were established. The current universe is the era of ongoing conversion economy operating at the calibrated proportions established by the early conversion era and maintained by the regulator function. The framework's account is naturally compatible with active mainstream research on vacuum phase transition cosmology. In plain terms, vacuum phase transition cosmology proposes that the visible universe emerged when an underlying vacuum field underwent a rapid phase change, a metastable medium precipitating into matter and energy. In framework terms, the rendering produced a supersaturated substrate, a medium initially holding conditions that exceeded its stable equilibrium, that instantaneously precipitated matter and energy as the conversion mechanism activated at cosmological scale. The supersaturated substrate is what mainstream physics has been describing through vacuum phase transition models without recognizing the underlying architecture. Sidney Coleman's 1977 paper, Fate of the False Vacuum, provided the theoretical foundation. Subsequent work has connected vacuum phase transition cosmology to inflation theory and bubble nucleation models. Both the framework and vacuum phase transition cosmology reject the matter from nothing framing. Both posit an existing substantive medium undergoing a formative event from which cosmic history unfolds. The framework's reading positions vacuum phase transition phenomena as the layer 3 visible signature of the rendering producing the substrate. The framework predicts that the calibrated proportion of matter and energy to substrate at cosmological scale is approximately 9% to 91%. This is the value of 1 divided by phi to the 5th power, where phi is the golden ratio. Phi raised to the 5th power equals approximately 11.09. 1 divided by that value equals approximately 0.0902, or 9.02%. The current mainstream cosmological estimate is approximately 5% ordinary matter and energy against 95% dark matter and dark energy combined. The framework's 9 to 91 prediction diverges from this estimate. The framework holds the fractal calibration as a load-bearing claim and predicts that cosmological accounting will eventually resolve at approximately 9 to 91 rather than at the current 5 to 95 estimate. Why is the framework so confident in this divergence? 3 reasons. First, the mainstream 5 to 95 estimate depends on substantial interpretive choices within the standard cosmological model. The estimate assumes dark matter and dark energy are separate substances rather than substrate manifestations. It assumes the cosmological principle holds at all scales rather than failing at the rendering boundary. Each interpretive choice feeds into the estimate. The framework challenges these choices. Second, the mainstream estimate does not fully account for all categories of energy and matter. Neutrinos are not fully integrated. Quantum vacuum energy is not included in matter accounting at all. The substrate carries its own intrinsic energetic structure that the standard model does not recognize. As accounting improves to include these categories, the meaningful ratio shifts. Third, the framework's reinterpretation of dark matter and dark energy as substrate manifestations fundamentally changes what the accounting is measuring. The meaningful ratio is matter and energy against the substrate itself. When the accounting is reframed in this way, the proportions resolve toward 9 to 91. The framework's wager deserves direct statement. The architecture is not adjusted to fit observation. The observation is predicted to refine toward what the architecture produces. This is what a framework with serious predictive commitments does. If cosmological measurement continues to support the 5% figure with increasing precision and rules out the 9% prediction, the framework's calibration claim fails. The framework accepts this risk. A framework that predicts nothing specific cannot be wrong in any consequential way. It also cannot be right in any consequential way. The framework wagers that the fractal architecture it identifies is genuine and that the cosmic proportions will eventually confirm the wager. The 9 to 91 ratio is not just a substrate property. It is the calibration the conversion economy actively maintains. We established the conversion economy in episode 5, substrate energy, matter, and propagating energy as 3 interconvertible forms, with the universal c-squared conversion factor governing modal crossings. The ratio is what the architecture defends as its stable equilibrium. Black holes are the cosmic scale mechanism through which the calibration is maintained. We established the regulator function in episode 5 at galactic scale. At cosmological scale, the picture extends. Supermassive black holes at the centers of nearly all galaxies regulate at galactic scale. Stellar mass black holes throughout galactic environments regulate at smaller scales. The cumulative effect across the universe is the continuous regulation of the matter-substrate calibration ratio. The conversion economy operates across all scales, Planck to cosmological, maintaining the same calibration. The universe is not winding down. It is not heading toward heat death. It is undergoing continuous regulated dynamics that maintain the conditions for the rendering process to continue indefinitely. The cosmological observations we make are not snapshots of a system running down. They are observations of an active architecture in dynamic equilibrium. What we framed in episode 5 as the conversion economy is, at cosmological scale, what cosmology measures. The fractal ratio, the regulator function, the conversion mechanism, the empirical signatures of substrate energy. All of these are aspects of one operating system observed at the largest scales. The active architecture's continuous operation has a consequence the framework holds with appropriate epistemic discipline. The universe may be much older than mainstream cosmology has estimated. The mainstream estimate of approximately 13.8 billion years is derived from cosmological models that interpret the universe as having a discrete origin in the Big Bang. We have reframed the Big Bang as the rendering producing the substrate with conditions sufficient for conversion. Once that reframing is in place, the 13.8 billion year figure loses its grounding as a measure of the universe's true age. The framework's account suggests this estimate may be a feature of observational limits rather than of the universe's true age. The rendering boundary at 300 million light years limits what can be directly observed of the deep past. The cosmic microwave background on the framework's reading may be the signature of the rendering boundary itself rather than a snapshot of an early universe phase. If the cosmic microwave background is the boundary signature, the universe's age is not constrained by the cosmic microwave background measurement. The continuous conversion economy implies an architecture without a terminal end state. There is no heat death, there is no unidirectional decay. The system regulates itself at the calibrated proportion indefinitely. The architecture is not running down. From the framework's account, it would be coherent to hold that the universe has been operating in continuous conversion economy for a duration substantially greater than 13.8 billion years, possibly much greater. The framework holds this proposition with appropriate epistemic discipline. The actual cosmic age may be substantially greater than 13.8 billion years, possibly much greater. Whether this is the case is a question that current observation cannot definitively resolve. The framework's contribution is the architectural account within which the question can be productively engaged. Part 10 is now in place. The rendering boundary, the cosmic microwave background reframed, the three dissolutions of dark energy and dark matter and quantum foam, the cosmic history of conversion with the vacuum phase transition compatibility, the cosmic fractal ratio with its 9:91 prediction held as load-bearing, the conversion economy at cosmic scale, the cosmic age proposition held with epistemic discipline. These are not minor adjustments to standard cosmology. They are a structural reinterpretation of what cosmology has been describing. We have engaged the largest scales. We turn now to the smallest. Part 11, Quantum Reconciliation. The framework's account of quantum mechanics begins with a direct architectural claim. Newtonian physics describes layer 3 dynamics for fully manifested matter. Quantum mechanics describes layer 2 dynamics and the layer 2/3 transition. The two are not competing accounts of the same phenomena at different scales. They are descriptions of different aspects of the architecture. Quantum mechanics was developed in the 1920s through the work of Heisenberg, Schrödinger, Born, Dirac, and others. Within a few decades, it had become one of the most empirically successful theoretical frameworks in the history of physics. What has remained contested for nearly a century is what quantum mechanics actually means. Multiple interpretations have been advanced: the Copenhagen interpretation, the many worlds interpretation, decoherence-based approaches, hidden variable theories, pilot wave theories. None has commanded consensus. The framework provides the underlying ontology that quantum mechanics has been describing without recognizing what it was describing. The wave function describes the field of possibilities at layer 2. Measurement is the rendering act that resolves a specific possibility into a layer 3 manifestation. The apparent indeterminacy is the multiplicity of possibilities held at layer 2 before rendering occurs. The apparent non-locality is the connection through layer 1 beneath the spatial separation of layer 3. Quantum mechanics has resisted intuitive understanding for a century because it has been describing a layer of reality whose nature is genuinely different from the manifest reality where classical intuition was formed. Once we recognize that quantum mechanics describes a different layer, the strangeness is what we would expect. The classical intuitions formed at layer 3 should not apply to the dynamics of layer 2. We engage the key quantum mechanical phenomena through this reframing. The wave function in quantum mechanics is a mathematical object that describes a quantum system's possible states. Its evolution is governed by the Schrödinger equation. The square of its amplitude, by the Born rule, gives the probability of measurement outcomes. The mathematics is precise and extensively tested. What the wave function actually is has remained contested. Is it a real physical object, a summary of an experimenter's information, a description of an ensemble of similar systems? Multiple interpretations have been advanced for nearly a century without consensus. The framework's reading is direct. The wave function describes the structured set of layer 2 possibilities that may be rendered into layer 3. The Schrödinger equation describes how layer 2 possibilities evolve dynamically. The Born rule describes the probability of rendering outcomes when a measurement triggers rendering. The wave function is not a ghostly probability cloud, and it is not a mere mathematical abstraction. It is a description of what layer 2 contains before rendering. This reading preserves all of the mathematics exactly. The Schrödinger equation continues to describe wave function evolution. The Born rule continues to describe measurement probabilities. What changes is what we take the mathematics to be of. The wave function describes layer 2. Measurement is layer 3. The transition between them is rendering. Superposition is one of quantum mechanics' most distinctive features. A quantum system, until measured, exists in a superposition of possible states, multiple values for its measurable properties held simultaneously. Wave function collapse is what happens at measurement. Before measurement, the wave function describes a superposition. After measurement, the wave function describes a single definite state. The transition has puzzled physics for a century. Schrödinger's famous cat thought experiment, developed by Erwin Schrödinger in 1935, captured the apparent absurdity of taking superposition to macroscopic scales. A cat in a sealed box with a quantum-triggered poison release would, according to a straightforward application of quantum mechanics, exist in a superposition of alive and dead states until observed. The thought experiment has been engaged philosophically for nearly a century without consensus on what is wrong with the apparent absurdity. The framework dissolves the puzzle. The wave function describes layer 2 possibilities before rendering. Wave function collapse is the rendering act that resolves those possibilities into a specific layer 3 manifestation. The Schrödinger equation describes how layer 2 possibilities evolve dynamically. The collapse is not a separate physical process imposed on the system. It is the rendering act that produces layer 3 manifestation from the layer 2 field. Schrödinger's cat in this reading is not in a superposed state at the macroscopic level. The cat is a fully rendered layer 3 manifestation. What is in superposition is the quantum trigger inside the box, the radioactive atom whose decay would trigger the poison release. The cat is fully alive or fully dead, depending on what was rendered for the atom. The thought experiment's apparent absurdity was a category error. Mainstream quantum mechanics treated a layer 3 entity as if it were a layer 2 possibility. The framework dissolves the category error. The observer effect is the empirical phenomenon by which the act of observing a quantum system alters the system's behavior. The decisive empirical demonstration is the double-slit experiment. Particles sent through two parallel slits produce different patterns depending on whether the slits are observed. Without observation, an interference pattern emerges, the wave-like signature of particles existing in superposition. With observation, the pattern collapses to two distinct bands, the particle-like signature of definite paths. The conventional reading has invited mystical interpretations for nearly a century. Does consciousness collapse the wave function? Is the universe somehow dependent on observation? The questions have produced extensive philosophical literature, but no consensus. The framework's reading is structurally clean. Observation is rendering interaction. Without observation, path information remains in superposition at layer 2. The interference pattern is the visible signature of layer 2 superposition. With observation, the measurement apparatus's interaction with layer 3 forces the rendering of path information into a definite state. The mechanism is not consciousness. The mechanism is the establishment of a coherence channel through layer 2 that activates rendering. The mechanism by which rendering activates operates through two channels. Decoherence through environmental interaction renders quantum systems through the natural dynamics of the substrate. Conscious observation by an intelligent system establishes a coherence channel through layer 2 that activates rendering directly. Both mechanisms operate. Consciousness is not metaphysically required for collapse. Measurement triggers rendering whether consciousness is involved or not. The mystery removed, the mathematics preserved. Quantum tunneling is the phenomenon by which particles cross potential barriers that classical physics would treat as impassable. The phenomenon has been observed and exploited across many contexts: the alpha decay of unstable atomic nuclei, the operation of scanning tunneling microscopes, the operation of tunnel diodes in electronics. Classical physics cannot account for the phenomenon. Quantum mechanics predicts it. The framework's reading is direct. Quantum tunneling is the visible signature of layer 2 possibilities not bound by layer 3 constraints. At layer 2, the particle's possibilities include configurations the layer 3 manifestation has not yet locked into. The classical potential barrier is a layer 3 constraint. Layer 2 possibilities are not bound by this constraint because they have not yet rendered into layer 3 form. The particle's layer 2 possibilities include both sides of the barrier. Rendering produces a manifestation on whichever side the rendering resolves toward. The probabilistic character of tunneling is the rendering probability governed by the Born rule. What appears as a particle tunneling through the barrier is the rendering of a layer 2 possibility that includes both sides. The mystery dissolves. The experimental results, alpha decay rates, tunneling current in scanning microscopes, tunnel diode behavior, are preserved exactly. The architecture's account of how layer 2 possibilities resolve into layer 3 manifestations explains naturally what classical physics treats as impossible. Entanglement is the deepest connection between quantum mechanics and the framework's architecture. In quantum mechanics, entanglement is the phenomenon by which two or more quantum systems share a correlated quantum state. Measurements of one entangled particle reveal information about its entangled partner instantaneously, regardless of the spatial distance between them. The phenomenon was first identified by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935 in a paper intended to demonstrate that quantum mechanics must be incomplete. Einstein famously called the apparent instantaneous correlation spooky action at a distance. The decisive theoretical development came in 1964 when John Bell proved a theorem now known as Bell's inequality. Bell showed that any hidden variable theory preserving locality must satisfy a specific mathematical inequality. Quantum mechanics predicts measurements that violate this inequality. The theorem provided a way to test experimentally whether nature is governed by quantum mechanics or by some hidden variable theory. The experimental record on Bell tests has been one of the most consequential empirical programs in physics. Alain Aspect's experiments near Paris in 1982 produced the first decisive experimental confirmation that Bell's inequality is violated. John Clauser conducted earlier Bell test experiments beginning in the early 1970s. Anton Zeilinger's group in Vienna conducted increasingly refined tests across the 1990s and 2000s. The 2015 loophole-free Bell test, conducted by Ronald Henson and collaborators at Delft University of Technology, closed the remaining methodological loopholes simultaneously. The 2022 Nobel Prize in Physics was awarded jointly to Aspect, Clauser, and Zeilinger for these foundational experiments. What the experiments establish is that nature does not have local hidden variables. The correlations between entangled particles cannot be explained by predetermined values carried by the particles themselves. The correlations are genuinely non-local. The framework's reading is that entanglement is the connectivity through layer 1 beneath the spatial separation of layer 3. All matter and energy were rendered from the primordium in the same act of creation. They emerged together from the same source. This shared origin means they remain entangled at layer 1, beneath the spatial and temporal separation of layer 3. The spatial separation that layer 3 produces is a feature of manifest reality. At layer 1, where the particles share their common origin, no spatial separation exists. This dissolves the philosophical puzzle that has surrounded entanglement since 1935. There is no non-local influence propagating through layer 3 space at superluminal speed. There is layer 1 connectivity that the spatial structure of layer 3 has not abolished. Einstein's spooky action at a distance framing was a layer 3 intuition applied to a layer 1 phenomenon. The action is not spooky. The distance is the feature of layer 3 that the layer 1 connectivity does not respect. The implications extend beyond the immediate experimental context. Entanglement is not a peculiar feature of certain quantum experiments. Entanglement is the fundamental connectivity of all rendered reality. Everything that has ever been rendered remains entangled with everything else because everything emerged from the same source. The careful preparation of entangled particle pairs in the laboratory makes this universal connectivity observable in a controlled setting. The connectivity itself is universal. The Heisenberg uncertainty principle, engaged in episode 5, takes its place in this unified treatment. The uncertainty is the rendering granularity at the layer 2/3 boundary made visible. The Planck constants are the quantization granularity of the rendering. The uncertainty principle is not strange. It is what the rendering granularity looks like from within layer 3. The mathematics of the uncertainty principle is preserved exactly. The position-momentum trade-off, the energy-time trade-off, the experimental confirmation across many contexts, all preserved. What changes is what we take the uncertainty to be of. The architecture's rendering operates at a specific granularity. The irreducible uncertainty in conjugate variables is what that granularity produces. Quantum mechanics measured the granularity without recognizing it as such. The measurement problem that has occupied quantum mechanics for a century is resolved within this account. Measurement is the rendering act that resolves layer 2 possibilities into layer 3 manifestations. The wave function describes layer 2. Collapse is the rendering. An observer is whatever layer 3 interaction triggers the rendering. Whether the interaction involves consciousness is irrelevant. The various interpretations of quantum mechanics that have been proposed for nearly a century, Copenhagen, many worlds, decoherence, hidden variables, pilot waves, have each addressed aspects of what quantum mechanics describes. The framework provides the underlying ontology that all of them have been attempting to articulate without recognizing what quantum mechanics has actually been describing. Each interpretation captured something. Copenhagen captured the irreducibility of measurement to the system being measured. Many worlds captured the apparent multiplicity of possibilities held before collapse. Decoherence captured the environmental contribution to collapse. Hidden variables captured the intuition that quantum behavior should have an underlying ontology. Pilot waves captured the wave function as something real rather than informational. The framework absorbs each of these insights and provides the architecture that makes them coherent together. Quantum mechanics is not strange. It is the physics of the layer where reality is rendered. The mysteries of quantum mechanics are the mysteries of how the architecture operates at its rendering interface, and the architecture has now been articulated. We have come a long way in this episode. Cosmology reframed as the visible operation of the conversion economy at the largest scales, dark energy and dark matter as substrate signatures, the rendering boundary at 300 million light years, the cosmic history of conversion with vacuum phase transition compatibility, the cosmic fractal ratio at 9 to 91, held as load-bearing, the cosmic age proposition held with epistemic discipline, quantum reconciliation, quantum mechanics as layer 2 physics, the wave function as layer 2 possibilities, superposition as layer 2's natural state, the observer effect as rendering interaction, quantum tunneling as layer 2 possibilities manifesting, entanglement as layer 1 connectivity beneath layer 3 spatial separation. The measurement problem dissolved. The framework's account of physics is substantially in place. 3 layers, 1 rendering process, the substrate's active architecture, matter as coherent vibration, energy as boundary phenomenon, time as layer 3 feature, the 4 forces as substrate coupling, gravity as substrate distortion, cosmology as conversion economy at cosmological scale, quantum mechanics as layer 2 physics. In the next episode, episode 8, we turn to the unified picture and implications. The synthesis of the framework as a whole, the falsifiable predictions catalog gathered together, the framework's relationship to other ongoing research programs that align with its commitments, what the framework does not yet solve, what remains for further development. We turn to it next. Thank you for being part of this journey.